Okay, so welcome back. So now in this video, what I'm going to talk about is another type of variation that is also related to direct variation. So far we've talked about variables that are directly related to each other, that vary directly, right? That are directly proportional to each other. Okay, so that one variable is directly proportional to another variable. We've also talked about the phrasing, like what if, when you look at a word problem, it says, hey, that one variable varies directly as another variable. But what about joint variation? Well, joint variation is just very similar to direct variation, except it's multiple variables. So let's say you've got one variable that varies directly as another variable, or not another variable, but two other variables. Okay? Let's say you have x, y, and z. And let's say you've got y, and y varies directly as x, but y also varies directly as z. So it varies directly with two variables. So we would call that joint variation, okay? Because one variable varies directly as two other variables or more variables, okay? So that's what we mean by joint variation, okay? So the only difference is that you're going to add, you have more variables than before, okay? So you're going to have the same sort of thing. So if I have, for example, ignore this for the moment, but if I have y as it varies jointly as x and z, let's say, then I know that if it varies directly, right? So if it varies directly with x, then I know it has to have this, right? Right? Is equal to k, right? And if y also varies directly with z, then I know y over z has to equal some k, so let's say k1 and k2, right? In fact, if y varies directly with x and y varies directly with z, then what we can do is, well, then x and z, we can say this. Y varies directly with x and z, we can put x and z both in the denominator, and then we know that has to be equal to some constant. And we will call this constant the constant of joint variation. So all you're going to do is you're going to have multiple things on the denominator here. That's it. So if you have one variable that is jointly proportional to two or more other variables, then you're just going to put those variables on the bottom, and then that ratio has to be constant. Okay, that's it. That's the only difference. So in other words, you could also, again, solve this for y, and then you get the the formula for solving joint proportional, joint variation problems. Then you get y equals k times xz. Okay, so that's where we're going. That's it. That's the only, so basically the steps are the same, except our formulas are different. Okay, so in this example here, again, the wording tells you, right? So it says find W if W varies jointly as X and Y. Okay, well, great. If W varies jointly as X and Y, then X and Y are going to be in the denominator. Okay? So that means when I set this up, that means W over what? Y and X must equal the constant of joint proportionality, okay, or joint variation. So now, what do they give us? Well, they give us information. So now that we got this set up right, now we just plug and chug. Well, X is 140, Y is 6, and the constant is 0.5. So guess what? I'm solving for W, right? They want me to find W. So W equals, right? So now I'm just going to rearrange this, and W equals K times Y times X, and K is 0.5, Y is 6, and X is 140. Okay? So, that means that this is going to be 420, right? Half of 140 is 70. 6 times 7 is 42. Add the 0. 420. Okay? So W is 420, and we solve the problem. Have a great day.